Good morning everyone. Today I am presenting this paper, Experimental Investigations of Plastic Solar Air Heater. This is actual research work done at Manipal Academy of Higher Education, Dubai campus, and the people involved here are Professor Faisal Akram. He was former professor, assistant professor at Mahia Dubai campus. The students, undergraduate students, Anuj Prashant, Nabil Ahmad, Swapnesh Panikar, Toba Sharif have helped in this project. Currently, I am working as Vice Chancellor, VIT AP University, Amravati, Andhra Pradesh. The contents of the presentation is the introduction, research gaps and objectives, construction and working of the plastic solar air heater, and what are the measuring instruments used, and after that I will discuss the results and the conclusions, nomenclature and references. Here you can see the plastic solar air heater. The cold air will enter from the bottom header and it gets heated up. As it moves, it gets heated up and then it will exit from the top header. You can see that the hot air which is coming, actually one of the applications is shown here on right hand side. You can see the cool air comes from the room and it gets into the air heater, and then afterwards it will be heated and then hot air will go to the room. One of the applications is room heating. Therefore, I am showing this example. Here you can see in the research gaps and objectives, in the air heating, space heating or any heating of the air, the payback period should be as low as possible. And if you use plastic materials, the payback period will be very low for solar air heating. Therefore, we thought that we should use low cost plastic as the material for the solar air heating. And the research work is very limited in that area because many people are not using plastics as the material. But actually I found that if you use plastics as the material, as the cost is low, the payback periods will be very, very low. The second objective research gap is the conducting a detailed study throughout the day and noting the input parameters as actually currently much literature is not available on this. Therefore, we thought we will get on to this research project. Here objectives are design and construction of the plastic solar air heater. That is the first objective of this research work. The second objective is determine the performance parameters by considering the input parameters. This is the second objective of the paper. You can see in this slide the construction and working, and here there are two headers, top header and bottom header and top header, and these two headers are connected by small pipes. You can see these are all small pipes. The small pipes are attached to both the headers, and these are also all are plastics, and these are actually welded here. The plastic tubes or pipes are welded to top header and bottom header, so that air will not leak. And over that we actually applied the black color, and this entire array of these tubes, pipes are kept in a wooden frame, and this wooden frame we made in such a way that we can fix the top cover to this. Without cover also we tested, with cover also, top cover also tested, and the results are shown. Then you can see here the construction This is the bottom header, and here it is the top header, you can see, and both headers are connected by the pipes. These are all small plastic pipes welded to the top header, bottom header and top header. And the inclination also you can see, this is the inclination required for the pipe, and we actually you can see in this figure. And we kept the top cover because of various reasons, and we tested the solar plastic air heater with top cover, without top cover. And the measuring instruments are thermometer to measure the air temperature. Air temperature range is -20 to 100 degrees Celsius. This is the range of the thermometer. And actually, these are all actually thermocouples, okay, which are actually used for this measuring the temperature. Anemometer, this is to measure the air velocity, and the range is given here, 0 to 50 meters per second, and threshold sensitivity 1 meters per second, resolution is 0.05 meters per second, and it is accuracy is plus or minus 3 meters per second. Results and discussions. Here you can see the readings. We started the first set of the readings are without cover. We have not used any top cover, and without top cover we have actually conducted the experiments. At that time we recorded the wind speed as maximum is 2.5 meters per second. It was varying 1 to 2.5 meters per second. You can see the inlet temperature at 10:30, 35 degrees centigrade, and the outlet 42 degrees centigrade. There is an increase in 7 degrees. As the sun moves, you can see at around 12 o'clock it reached up to the differences. The temperature difference between inlet and outlet reached to 14 degrees centigrade, and afterwards 1 o'clock onwards it actually diminished. This is what actually without cover. These are the readings. Here in this, the maximum temperature rise is from 42 degrees centigrade to 56 degrees centigrade, that is 14 degrees centigrade. And the calculations are done using these two equations majorly. One is the heat gained by the air, the mass flow rate, specific heat of air, and the change in temperature. And efficiency of the collector is the heat gained upon the intensity of solar radiation. The second, table number 3, you can see here the experimental results with the plastic solar air heater with cover. Wind speed is 4 to 4.5 meters per second. You can see here the rise in temperature is high because we have used the top cover. Top cover reduces the losses. Because of reduction in the losses, we can see rise in temperature also more. As usual, you can see but here in this case at 1 o'clock, you can see the maximum temperature rise. That is around 33 degrees centigrade. On a specific day, the rise in temperature at 1 o'clock is very high. Then afterwards, slowly it is diminishing. The air entered at 33 and is coming out at 66 degrees centigrade. The rise in temperature is 33 degrees centigrade, which is quite significant. And here you can see the experimental results on the graphs. As the first graph here is influence of air flow rate on efficiency of PSAH using top cover. Now you can see the efficiency is increasing as the mass flow rate is increasing. Then the next graph is comparison of efficiency of plastic solar air heater with and without plastic cover. Without top cover, definitely the efficiency will be low, and with top cover the efficiency is high. You can see the maximum efficiency with the top cover is at around 1 o'clock, and which is almost equal to 70%, and is quite good efficiency. And with cover the system is working very fine because the losses are minimum. The top losses are very minimum because of the outside wind on the top on the top of the solar collector. The variation of heat transfer rate with and without plastic cover, you can see with the plastic cover the heat transfer rates are very high between air and the incident solar from the sun. The conclusions are: results indicates that efficiency without cover is 30% and with cover is 70.57%. Collector efficiency rises with increase in airflow rate. Maximum efficiency is 70.57 of plastic solar air heater with top cover was achieved at the airflow rate of 0.051 kg per second. The system cost is very less and less maintenance, and maximum heat transfer without cover observed is at noon, and the value doubles when the top cover is provided. Maximum value of heat transfer is observed at 717.57 watts and 1691.47 watts respectively. This work can be further expanded by using computational fluid dynamics method for the better understanding of the fluid behavior with appropriate boundary conditions. Materials properties can be varied and experimentation can be done again. That is actually the future work of this project. And here the nomenclature are given in this slide, and you can see various references. This can be seen in the paper also. And thank you very much for listening to me, and if you have any queries I can address them through online. Thank you so much.